Hello, this is checkpoint 2.54. They want us to identify the surface represented by this equation. It's 9x squared plus y squared minus z squared plus 2z minus 10 is equal to 0. So because we have all of the variables are being squared, means that this is probably going to look something like either an ellipsoid or a hyperboloid. And because one of the signs in front of the x squareds or y squareds or z squareds is negative, and it's probably not going to be an ellipsoid, it's probably going to be a hyperboloid. And because two of them are positive and one is negative, probably means that it's going to be a hyperboloid of one sheet. And the other part of that is that there's another component here that's not squared, another variable that's not squared. And so this will take it, the center point is usually at the origin, and because there's something happening here means it's not going to be at the origin. And so the process for trying to figure this out is to complete the square. So that's what we'll do. For us to complete the square, one of the things that we can approach, one of the approaches is to bring the constant on one side and group all the terms with the same variables together. The x squared and the y squareds don't have any other variables associated with them, but the z squared has. And what we'll do is we'll take the coefficient of the z, which is a -1, and factor that out of all the z terms. And so we'll keep this in parentheses and we'll factor out a negative sign, -1, and we'll have a -2z left over. And I'll leave some space here because we will complete the square and then rewrite this as something squared. And we'll bring the constant to the other side, so that will be a +10. Now, what are we going to add inside? In order to complete the square, we're going to take a look at the middle term, which is 2. We'll divide it by 2. We'll cut it in half. And then we'll square that. And then we get 1. So 1 is going to be the number that we're going to add to both sides. Now, we're going to add 1 in here, but we have to be careful what we're actually adding on the other side. So we added a 1, but we didn't really just add a 1. We also added a negative sign over here. So what we need to add is not just a 1, but actually a -1. Okay, so what we really added on the left-hand side is a -1, and so we have to add a -1 on the right-hand side. Okay, let's continue on. We have a 9x squared plus y squared. Now this is a perfect square because we just completed the square. And we can identify the complete square by the variable, just raised to the first power, the sign that we have here, which is a negative, and then the square root of this number, or half of this number, which is 1. And then we'll do the arithmetic on the right hand side. That's 10 minus 1 is 9. Okay. To make it look like in standard form, an equation in standard form, what we're going to do is we're just going to divide out by 9. So we will have x squared divided by 9, and so that will go away. We have y squared divided by 9, and z minus 1 squared divided by 9. And then we could look at 9 as 3 squared also, so we could do that, or we could just leave it like that. In any case, this is going to be a hyperboloid of one sheet, because we have 2 positive numbers, or 2 positive terms and 1 negative term. And the center point, so let's identify that we have a center. And the center point is going to be 0, 0, and 1. Okay, so if we try to draw this, we could just draw our usual X, Y, Z. And we'll draw the center point over here. And if we want, we can identify the cross-section cut or the trace when it would probably be best when z is equal to 1. So when z is equal to 1, this term will be 0. And then you have an ellipse, x squared plus y squared over 9 is equal to 1. And so maybe we'll make a note of that. When z is equal to 1, we're going to get x squared plus y squared over 3 squared is equal to 1. And I put 3 squared there because that'll give us the y-intercepts. So up here, we go 1 unit along the x-axis and 1, 2, 3 units along the y-axis. 1, 2, 3, and another 1 unit back. So we have an ellipse. And that's kind of like the center cut, and everything else will just look like a hyperboloid. All right, that's your hyperboloid of one sheet. Maybe we can write it down. Hyperboloid of one sheet and centered at 0, 0, 1. Okay, that's it. Good luck.